I'm Suraj, and today we are going to talk about how to not break GraphQL clients. Let me introduce myself. My name is Suraj. I am a senior engineer at CrowdStrike. I work for their API team with REST, gRPC, and GraphQL. Currently, I'm leading efforts to build federated GraphQL platform at CrowdStrike. So let's start with the presentation. So you have built a GraphQL API, and now you have some clients using your API. You want to make changes to your schema, and you want to make sure whether your changes will break your existing clients or not. General advice, try not to make breaking changes. But as you already know, it's easier said than done. If it is possible, use deprecation, but that's not always the solution. Also, try to find unintentional breaking changes during development. There are various schema comparison tools which you can use to find breaking changes. You can run them locally or plug them in your CI to find breaking or dangerous changes. But the tools can only take you so far. Today, I want to talk about the changes schema comparison tools find and what we can do about those changes. So here's a list of breaking and dangerous changes as defined in GraphQL JS library. Most of the libraries categorize these changes in three buckets: safe, breaking, and dangerous. Safe changes are the ones which you can make without worrying about, without it impacting your existing customers. Breaking changes are the ones which will break your clients, and dangerous changes are the ones which won't actually break your clients, but they will change their behavior in a negative way. Let's go over these changes one by one. So let's start with types and fields. Removing a field. It's obviously a breaking change. Existing clients querying a field which has been removed by the server will result in an error. So let's say you remove commentary string from review, your existing queries having that field will result in a validation error. The right way to remove a field is to mark it as deprecated. Deprecation directive should contain reason, and the reason string can have more information like alternate fields to be used, sunset date, etc. The deprecation should be communicated to customer through documentation, emails, and as GraphQL response extension if they are querying deprecated fields. The usage of the deprecated fields should be monitored. It would be safe to remove a field which is no longer in use. If the field is nullable, it is just easier to return null value or empty value for this field after the sunset date so as to not break your lagging older clients. If the field is required, then we can't do that. Changing field kind. If you change a field type, then existing client queries will break. But there are certain caveats. For example, changing a field from string to ID is not a breaking change. Since ID is represented as a string, changing a field from string to ID is totally fine and not a breaking change. Making an optional field required is also not a breaking change, even though it is reported as breaking change by schema comparison tools. Removal of types. Since deprecated directive is not supported for types, we can't deprecate the type as is. Instead, we can focus on fields using this type. We can deprecate the fields using this type and put description with alternate fields to use. Once all the fields using this type are deprecated and removed, the type can be safely removed from the schema. Let's go to arguments. Adding arguments. This is one of the most common use cases while evolving schema. That's how we evolve fields in general, right? Instead of making fields with suffix v1, v2 for every new argument, it is possible to evolve them without breaking existing clients. In this case, let's say you add a new argument is human to an existing field, This is, of course, going to break the client, right? And it does. Existing client querying, client making this query will fail with a validation error because server now expects is human argument and existing queries are not going to provide that. But there is a way to fix this. A default value can come to the rescue here. Adding default value allows server to be compatible with older clients while letting you add new functionality. How about removing an argument? It is understandable that removing a required argument is a breaking change and why it would break clients. But shouldn't it be okay to remove optional argument? GraphQL spec says no. Removing argument, optional or required, would result in validation error for existing queries. If a query is specifying something which the server doesn't understand, of course, it is going to return validation error. So what can we do? Well, just like fields, arguments can be deprecated. So we can follow the deprecation steps to remove arguments too. What if I want to change the argument kind? Changing kind is a breaking change. For example, if you are changing unit argument from a string to an enum, existing client queries will fail with validation error, since the server doesn't know how to transform foot string into a length unit enum. But there are scenarios where it is actually okay if you make this change. For example, changing an argument from string to ID is fine. Changing an argument from int to float is fine too. Changing an argument of a type to an array of that type is also fine. This is because of input coercion. Existing queries won't actually break here, and new queries would still be able to work. If an argument is made optional from required, the change will still be considered an argument kind change, which is categorized as a breaking change by schema comparison tool. But again, this is fine too and won't break your existing clients. Adding an optional argument is not considered a breaking change, but clients can see unexpected behavior as the response could be different, even though the query hasn't changed, the data hasn't changed. So the behavior can be made backward compatible with a default value whenever possible. This is not always easy to do with non-Boolean arguments, though. Changing default value could change clients' behavior in unexpected ways, but it won't technically break existing client code. Imagine default sort order is ascending and you change it to descending on server side. Client using older queries, assuming the order will be ascending, will start showing data in a wrong order, thus resulting in a bad consumer experience. We have to be aware of these scenarios before making dangerous changes. Removing default value is basically making it nil. Again, this is a dangerous change and client can behave in unexpected ways. Enumerations. If enum values are used as input fields or arguments, then removing of enum is a breaking change. Existing client queries where they are specifying the enum value which is being removed will result in validation error. If enum value is used as a field type, then existing queries won't actually break. They won't return validation error, but client can have unexpected behavior. Imagine client making a decision on type of enum it receives. If you remove an enum value from server, the client doesn't know what to do and it will behave unexpectedly. If a value is added to an existing enum, existing client queries would continue to work. But if client is assuming that these are the only possible values for this enum, then there is a scenario where it would result in unexpected behavior. Having a default clause for such cases can protect client from breaking if the server expands possible values in future. Let's go over to unions. Adding a union type. Server now has one more possible value it can return, but the client does not know about this new type, and that can result in unexpected behavior. Before adding Droid to search result union, this is how we would query. We would specify human and starship inline fragment, and server would understand that and it return the data. But when we add Droid to our search result union, server knows about Droid, but the client does not. And when you make this query without specifying Droid inline fragment, server can return an empty object like this. This can break clients. So how can we avoid this scenario? We can use type name, and we can use type name in the query, and the return type name can be used by client to make decisions on union types. That way, client can access fields on type it already knows about and ignore others it doesn't know. For example, in this case, if the type name is human or starship, client can know what to do, but if it is Droid, it can just ignore it because it doesn't know about Droid. Removing a type from union is a breaking change. Existing client queries will get validation error since server does not know about this newly added Droid in search result union. Instead of removing the type from the schema, server can just stop resolving this type. For a list of unions, not returning one of the type in the union would be fine, and client would continue to work. For objects, server can return null for one of the type of the union, and that is still acceptable. For example, in this case, server can just stop resolving Droid, and you will not get Droid in the response. But if a union is marked as required, then returning null value won't be possible. Interfaces. Removing an implementation of interface from schema will break clients. Let's say there's a character interface with human and Droid implementations, and now you want to remove Droid. Why would removing an interface will break clients? Because if the interface had fields in addition to if the implementations had fields in addition to interface fields, client has to use inline fragment to get those fields. For example, here, ID and name are interface fields, but primary function and height are additional fields on Droid and human respectively. So if Droid implementation is removed, server now cannot understand Droid inline fragment, which is specified in the query, and thus it returns a validation error. Adding an interface is only a breaking change if client is not being defensive about it. In this case, we have character interface and human implementation of that interface. We also want to add Droid implementation. For example, in this case, we have a human implementation of character interface, and our query is working like this before we added Droid implementation. But when server adds Droid implementation and client does not know about it, it can return empty Droid objects since we are not specifying any inline fragments on it. To avoid that, again, client should use underscore type name in the query. If underscore type name returned is not a known type to client should just ignore it. This is very similar to adding types to union. Let's move on to input types. Adding a required input field will break existing client queries unless a default value is specified. In this case, sort key is newly introduced required input field without a default value. And so existing client queries for this will result in validation error. Whereas in this case, sort by is a newly introduced required input field with a default value. And so existing queries will still continue to function even after adding a required input field. With default value, client can show unexpected behavior though. For example, if server was sorting by recently updated order, a customer could see the review they added immediately. Now that default value is provided, which is not same as recently added, older clients, they won't see the review a user is adding immediately. These scenarios need to be considered so as to cause least damage to existing clients. Adding an optional input field is not considered a breaking change, but similar to optional argument, client can see unexpected behavior. In this case, adding optional sort by reviews, sort order could be different than before. The behavior can be made backward compatible with default value. This will only work if server already was sorting by recently added key before this change. As you can see, default values do not always make sense, and you should only use if the client behavior isn't going to drastically change. GraphQL directives. GraphQL directives are generally defined on executable directive location or type system directive location. It is technically possible to specify it on both locations. Executable directive locations are operations only locations, for example, field, fragment definition, inline fragment, etc. Type system directive location are schema only location, for example, field definition, argument definition, etc. If the directive being removed is defined exclusively on schema, then it shouldn't break lines, but it can change their behavior. But if the directive being removed is defined for operations, then it can break lines. Existing queries containing this directive will result in validation error, just like removing types, fields, or enum does. In this case, for the sake of the example, let's say we are removing skip directive from schema. Skip directive is being defined on field, fragment spread, and inline fragment. What will happen to existing queries? Well, existing queries containing skip directive will result in validation error saying skip directive is unknown. But if we remove a type system directive like deprecated, there's no problem. Removing argument on directive. Removing argument, optional or required from a directive, is a breaking change. And existing clients will fail with validation error with updated schema. Like removing directive, this change will not break client if the directive in question is specified on type system locations. Adding a required directive argument. Like adding required argument on field, this is a breaking change and will result in validation error since existing client queries won't have newly added required argument. Again, this can be fixed with a default value if it suits your use case. Doing this for type system directives won't break existing queries and is generally safe, but directive location being removed is one of the executable directive location. For example, if you are removing a directive location and the directive location is one of field, fragment definition, or fragment spread, inline fragment, then it will break existing queries. For example, in this case, let's say we removed skip from field location. Existing queries which have skip on field location will return validation error. And with that, we have reached the end. Evolving your schema in backward compatible way forever is easier said than done. With this presentation, I hope I shedded some light on caveats of schema evolution and limitations of schema comparison tool. I hope now you have more information to make decisions while making changes in your GraphQL schema so as to not break your GraphQL clients. Thank you.